Hi guys, it's Mrs. Seitz. Today what you're going to be learning is, as we start a new unit, we're going to be starting on triangles in this unit. So the two main questions you're going to be able to answer by the end of today's today's class is, how do you classify triangles by sides and angles? And how do I find the measures of triangles, or find the measures of angles in a triangle? So this should seem like a review for you guys, but it's sometimes good to make sure you go over these things, especially if we get into further things with triangles. So the first thing we need to do is to classify a triangle by sides. So if you have three congruent sides, and remember, we show congruence in any type of shape with these little tick marks. So if you have three labeled congruent sides, this would be considered an equilateral triangle. If you have at least two congruent sides, we call that an isosceles triangle. And if you don't have any congruent sides, we call that a scalene triangle. If we were classifying a triangle by its angles, we would want to take a look at the angles inside of the triangle. So if I see that I have three angles that are less than 90 degrees, then I would be saying that this would be an acute triangle. If I'm saying that I have three angles inside that are all congruent, and for those all to be congruent, they would have to be 60 degrees, right? Because in a total degrees in a triangle, it would have to add up to 180 degrees. So 60, 60, and 60 would give me 180. This would be considered an equiangular triangle. If you have one right angle in a triangle, we consider that to be a right triangle. And if you have one obtuse angle within your triangle, it is considered to be an obtuse triangle. So it's really important to know if you're classifying by side, so equilateral, isosceles, or scalene, or classifying by angle, so acute, equiangular, right, or obtuse. So let's practice doing that right now. So if you take a look at the first example, we're going to classify each triangle and be as specific as possible, because sometimes it can be more than one thing. So it says angle or triangle ABC has two acute angles, so we see those, one right angle, and two congruent sides. It is a blank triangle. Well, if we go by angle first, I can see that I have one right angle, so that means this is considered to be a right triangle. So if I'm considering just by angle, if I'm going off of the sides, you can see that there are two sides that are congruent. Because I have two sides that are congruent to one another, it would be considered an isosceles triangle. So this would be a right isosceles triangle. In B, we're going to go with that same method, first angle, then side. Triangle DEF has one obtuse angle and no congruent sides, so it is well, if I'm going with obtuse first, it has the one obtuse angle, so it's an obtuse triangle. If it has no congruent sides, by definition, it would be a scalene triangle. So this would be considered an obtuse scalene triangle. All right, another important theorem for us to remember as we come across triangles, and I think you guys know this, and I said this earlier too, the sum of the measures of the interior angles of a triangle is always 180 degrees. So if you add up the measurement of angle A, the measurement of angle B, and the measurement of angle C, it's going to equal 180 degrees. Okay, this might be one though that we don't know. There's exterior angles whenever we take a look at triangles. So an exterior angle would be this angle that's on the outside of the set of the triangle. So this angle 1. The measure of an exterior angle of a triangle is equal to the measure of the sum of the measures of the two non-adjacent interior angles. So non-adjacent would mean that it's not touching angle 1. So that means if I'd be looking at that, I'd be looking at angle A and angle B. So if I add up the measurement of angle A and the measurement of angle B, it's going to be equal to the measurement of angle 1. A corollary, here's a new vocabulary word for you guys. I'm going to write this off to the side, and I recommend that you guys do too. A corollary in geometry or in math class in general is a statement that can be proved easily using a theorem. Okay, let me spell that a little bit better for you guys. Theorem. Okay, so corollary is a statement that can be proved easily using a theorem. So the corollary to the triangle sum theorem is the acute angles of a right triangle are complementary. So that would have to mean if I would add up the measurement of angle A and the measurement of angle B, it would have to be 90 degrees. And that kind of makes sense because if we think about that, the total degrees in a triangle has to be 180 degrees. And if you already know the angle C is 90, 180 minus that is 90. So when you share angle A and angle B, it has to be 90 degrees total. Okay, we're going to practice this exterior angle theorem right now with example 2. So you can apply this right now to find the measure of an exterior angle shown. So first, what you want to do is take a look at what we're trying to solve for. Here is your exterior angle. It's the 2 times the quantity of x plus 4. Remember, the exterior angle theorem says if you take your 2 non-adjacent sides, or 2 non-adjacent angles, so x and 50, and you add them together, you're going to get your measurement or for the outside of the exterior angle. We're going to apply that right now and help us to solve for x, which will ultimately we'll plug in and figure out what the measurement is for the exterior angle. So I'm going to do some work off to the side here and do some work in between so that we can get our measurement. So let's do this down here. We have x plus 50, which is our 2 non-adjacent angles. And then I'm going to distribute the 2 with the x and the 2 with the 4. So I have 2x plus 8. All right, I want to get x by itself, so I'm going to subtract x to both sides. So I'm going to have 50 equals x plus 8, and then I'm going to subtract 8 to both sides. So I'm going to end up with x to be 42. All right, so 42 is my answer for x, but I want to ultimately find the measurement of that red angle that I have up here. So I'm going to plug in 42 in for x. So the measure of the exterior angle would be 2 times the quantity of 42 plus 4. So when I calculate that, that's going to be 2 times 46, right? Which would be 92 degrees. All right, so right now, guys, let's pause your video and see if you can answer these 2 checkpoint questions correctly. The first one is to classify the triangle by its angles first, and then its sides. And then for the second one, you are going to be finding the measure of the exterior angle shown. So remember, guys, if you're going by angle, we want to take a look at all the angles that I see. I see a right angle, so this would be considered a right triangle. And if I look at the markings on this triangle, I don't see any, so therefore this would be considered a scalene triangle. So if I'm classifying this in total, this would be a right scalene triangle. All right, applying that exterior angle theorem, I know that the exterior angle, so the 3x plus 10, is equal to the 2 non-adjacent angles added up. So x plus 70. So when I start solving for x, I'm going to get 2x plus 10 equals 70. I'm going to subtract 10 to both sides. I'm going to get 2x. I'm going to do that up here. Equals 60. And then I'm going to divide both sides by 2. So I'm going to end up that x is equal to 30, but I want to find the measurement, right? So I'm going to plug in my answer for x into this expression of 3 times the quantity of, or 3x plus 10. So I have my 3x plus 10. I'm plugging in the 30. So I have 3 times 30 plus 10. So the measure of that exterior angle would have to be 100 degrees. So the main ideas are from this lesson: can you classify a triangle by its angles? So that would be right angles, right triangles, acute triangles, obtuse triangles, and equiangular. By sides would be equilateral, isosceles, and scalene. The other parts of today's lesson: do you know that a triangle adds up to 180 degrees? And also the exterior angle theorem. When you have your exterior angle, it adds up to the two non-adjacent angles. Hopefully you did well with today's lesson.